Thanks for joining. Today is day number 15, and we are continue to discussing our QS, quality of service topic. And let's see that what remaining topics we have related to QS. Let's try to understand this. So far we have learned about the DSCP, differentiated service code point. We know that TOS having COS and DSCP means layer 2 marking and layer 3 marking. And once we have the classification of the traffic, classification and marking of the traffic, then what we want to do? Then we want to do some sort of queuing mechanism. We want to queue the traffic. So high priority traffic will go with the high priority queue. Low priority traffic will go with the low priority queue and all, right? Now, once you go and provide the queuing for the traffic, then what you want to do? So now you will see here that this is not end of the QoS session, that you have done the classification marking, you have done the queuing, but apart from that, you can go and put some other mechanisms as well. So you can go and put some sort of bandwidth percentage reservations, such as policing and buffering. You can go and do some sort of scheduling as well, some sort of tail drop as well. So those topics we'll go and discuss today. So let's quickly go and see the full-fledged example related to the QoS. Now in this diagram, you can simply see that I have one hardware which is supporting 2 priority, 6 queue and 3 threshold. So now you can see that priority queue 1 and 2, they are nothing but the queue, right? So 1, 2, 3, 4, 5, 6, 7, 8. That means I have total 8 queue, right? 8 queues, they are supporting all those features. Clearly you can see here that we have queues. You can see the queues, and then you can see that we have the scheduling as well. So what does it mean by scheduling? I should show you this within the example as well. Okay, and you can see this. This is actually a very interesting diagram that you should understand. So now you can see that we can go and do the classification. So here I am doing the classification of traffic, right? And as per the class, we are mapping these classes to the queue, right? So some has high priority, some has low priority. Now within the queue itself, if you see that we are reserving the bandwidth reservation 10%, 10%, 5%, 10% for priority queue, 20% for priority queue. Now, in this, like in normal routers and switches, you can go and do this configuration. And in SD-WAN also you can do the configuration, but we know that in SD-WAN we have some GUI as well. So in GUI you will see in SD-WAN that you have one pie chart. That pie chart should be 100%. That means that all these bandwidths that you will go and add, they will become 100%. So here you can see 10 plus 20, then again 10 bandwidth reservation. So 40, then 10, 50, then 10, 60, 70, and then 5 plus 25. This is total 30. So you can see that bandwidth that you are reserving for different classes, they are becoming full, they are becoming 100%. Right? So you can go and reserve the bandwidth for high priority queue for 10, 20. And this is actually the real, you can see that best practice example from Cisco. Cisco will tell you to create your classes like this, means do the classification for traffic like this, and then do the queuing. So we are doing classification and marking, and then what we are doing the queuing, right? Queuing mechanism. So the first thing that we are doing is classification and marking, C&M. Then we are doing queuing. In this queuing, we have normal queue and we have priority queue, right? Then third, what you are doing is you are doing bandwidth reservation, right? You're reserving the bandwidth for certain traffic, high priority traffic, low priority traffic, or the volume of traffic. According to the volume of traffic, you can go and reserve the traffic. After that also, to do the queue management, to do the packet loss management and all, you can go and use certain different techniques. So last thing that you will do here is this, that you can go and use either tail drop, or you can go and use weighted early random detection. You can do scheduling as a round robin. Like some other methods are also there that we can go and use, but applying these complex queuing methodologies, you should know that you have these requirements, right? All these things are coming with requirement. If you do not have requirement, then do not go and utilize everything, all the possible QS tools that you have with you. Okay. So here you can see that weighted tail drop, bandwidth remaining percentage, or bandwidth reservation percentage is like this. It should be 100%. So suppose if you are giving 10% for priority queue, then again 20% for priority queue, then how much bandwidth you have left? 70% remaining, right? Then again from 70% you will go and reserve the bandwidth according to the remaining bandwidth percent, right? These examples we have seen earlier. So now this is one of the good example we have, where you will see that you can go and create the class was, you can go and give the priority, because you have two priority levels, so priority level 1 and priority level 2. But point here is this, that you can go and use the keyword called police. So now you are giving the 10% of bandwidth, 20% of bandwidth. Then for class control management, remaining bandwidth you are giving 10%. Then you are giving buffering as well. Buffer means it will go and buffer some of the traffic if it is required. Then you can see the multimedia queue, remaining bandwidth percent you are giving 10%, buffer you are giving 10%. And then we have rest of the queues where we'll go and assign the bandwidth. So here you can see rest of the queue in this line. So you have multimedia streaming as 10%. Then you are giving the buffer for 10%. Then you will see that transactional data, that's also one queue, 10%, then 5%, and then 25%. So this is actually the CLI configuration of this particular diagram. This is the configuration, right? So you do not need to understand this Q limit, DSCP, AF%. It's like little bit advanced configuration that Cisco is giving. It's related to tune the weighted tail drop, but you have other options as well. If you do not use this tail drop option here, then Cisco will go and do their default tail drop. So generally you will not see this Q limit, DSCP percentage and all tuning the tail drop percentage. But You will see 100% configuration related to the bandwidth percent and this. These two lines are very important. It will be there in our SD-WAN configuration as well. So assigning the bandwidth and then you are doing the buffering. Okay. So this is actually the base configuration. I'll give you one assignment that in your lab that you have, any lab, even I can book the lab and I'll share with you. So let's do like this. Today I will share two lab, one lab with Eric and one lab with Temi. That's the lab that this lab I'm talking about last time that we have done. One second. Go ahead. I need the Cisco any connect session. Let me quickly connect to the lab. So I was showing you about this YouTube video. Let me quickly give you the link there in the chat window, so you don't need to go and search for the record. Oops, this link. Okay, and where it is here. So this YouTube video. In this YouTube video, the timing is 59 minutes. If you go and start the video from 59 minutes, so you'll get little bit sneak peek of this viral. Anyways, I will also show you in the lab, but you have this video as well. Why I'm sharing this video to you? If you want to learn ASA from your own, you can go and watch this video. It's like theory plus lab. It's a complete package. You can learn ASA firewall from your own. You don't need any tutorial for that. 100% you will learn and understand ASA from your own. So that's why I'm pinging you this link here. And can you put hi in the chat? I'm not seeing this chat window. Where is this chat? That's the problem with Zoom. Sometimes we are missing the chat. Okay, I got it. This is the link. 59 minutes. If you want to see that viral will start from 59 minutes. For 5 minutes, you can see that. Okay. Now, why I'm going to give you this viral lab? Because if you see our lab here, we have something related to Nexus as well. Okay. And in the viral, you have this, you can go and drag drop the Nexus images as well. Okay. So you will see Nexus OS 9000. That means that you can go and try Nexus related little bit configuration as well. That is not part of your exam, ASA and Nexus, but just for your understanding, you can go and do that as well. So likewise, you can go and configure the 3850 QoS, and then you can go and apply to the policy map class default like this to give some shaping as well over the interface as well. Once you have this, right, you can see this is the nesting of policy. Within one policy, we are calling other policy, and this 2P6Q3T we have created here. This is our policy map. This policy we are calling under other policy, where we are applying the shaping methodology, and then we are applying this main parent QoS to the interface. Likewise, you can go and create and apply the QoS for 6000, 6500. Same QoS is there, but the Nexus QoS is different. The QoS is same, but this CLI configuration is very different than the normal QoS, and I don't think so that I have lab related to this. Let's just be there with me. If I have lab example related to Nexus, otherwise I'll fetch that lab for you and I will give you. So I am not seeing Nexus related QoS example, but good thing about Nexus, that QoS configuration is already there in all the Nexus platform. So if you go and check the running configuration, you will see such type of QoS configuration as well. Such type of QoS configuration as well in the Nexus platform. Yeah, you have any question? Please ask.
For the moment.
Right, so I have booked the lab and maybe it will start in 10 minutes. So today by the end of session, I will hand over the viral lab to you and I'll show you that how to start 2 routers and log in and perform basic tasks. So today I'm going to show you that. Okay, so we have almost completed our QoS related to wired routers and switches. There are some small topic related to wireless as well. Although wireless is not part of our training, because you know that CCI wireless is different and all those topics are there in the CCI wireless. CCI wireless or CCI enterprise wireless, that track is different. But in this slide, just for your understanding, I have put some slides, maybe in future if you have something related to wireless coming in your organization. So you can understand that in wireless, we have only 4 level of service, right? In LAN, we have 8 level of service, means you can go and create 8 different queues. But here you can see that all those 8 queues, you have to go and map in 4 queue. Okay, so that means that these 4 queues that you will create, you have to create like voice. So you have voice, high priority, low priority, and the least priority. Like that, you have to go and map it. Okay, so you can see the classes here: voice, video based effort, and background. It's like wireless. So whatever 8 queue you have, this 8 queue is mapped in this 4 queue. And in wireless terms, you will, if you go and learn wireless, you'll see that you have platinum services, gold services, silver, and the bronze services, right? That is mapped with the voice, video, best effort, and background. This is the wireless QoS. Actually, it is easy how we are applying, and we are applying these policies from the wireless controller, which is GUI based. So from the GUI based controller, you can go and create these services and apply to different access points. At 2015, you can see the mapping from 2015, that 4 categories, means we have only 4 classes that you can go and define. You can go and apply these 4 categories to the wireless. And then some theory I have given just related to QoS design, that we can go and have a look on that. Okay. So we have completed our topic related to QoS. It is actually lengthy and big topics we have. So only one part is remaining, that can I go and show the sample configuration? This is the sample configuration that I will show you. I will log into the router and I'll configure this. You will see that. Okay. Rest, the difficult part here to understand the classification of traffic, that is the DSCP marking and all. Then how you are mapping the classes to the queue. Once you are mapping classes to the queue, how you are reserving the bandwidth. Once you are reserving the bandwidth, then how you are providing the tail drop, how you are managing those drop packets like tail drop, weighted random, early detect, and others. And then finally, how you are doing the policing and shaping to the interfaces. to the classes, right? That is whole and soul of QoS. You will not see more than this anywhere related to QoS. Okay. Okay, so before going further, what we'll do, we'll go and do the CLI. I will go and do the CLI configuration for this QoS, and you also has task that you have to go and create the CLI configuration. Create one assignment. Try to understand these configuration. Put it in somewhere in Notepad or something that, as a standard configuration for your understanding, right? Now, what is next topic? What we are going to study next? That I have given you one break here. I don't want to start new topic because this new topic is this section, that what is CEF, Cisco Express Forwarding, MAC address, and how this TCAM table builds. What is FIB versus RIB? You know what is FIB and RIB? Any idea? So after this session, after next session, you will understand this 100%. What is Cisco Express Forwarding, MAC address table, and TCAM table? What is FIB and RIB? If I ask you that what is routing table, you know that what is routing table?
Mm-hmm.
Yeah, definition of routing table.
A list of routes you are learning, or list of network that's connected. It depends, you know.
Yeah.
So this QoS, is it part of the CCI syllabus?
No, not there in
Okay.
CCI.
Okay.
US is not there in CCI, yeah, but you will get it QS in everywhere, right? In okay, so what I'm telling that what is routing table, right? Let's try to understand the routing table, and then anyways we have class. So in the class you will understand the class related to fib and tib. You will understand what is fib, what is lib, what is rib, etc. So what is happening, you know, that you have your LAN network. So this is your LAN network, and your workstation PCs are connected within the LAN network. So let me go and one second, let me go and draw this. So I have the LAN. Suppose this is the LAN switch, and with this LAN switch, this LAN switch, let me go and connect quickly. 3 PCs are connected. Think that these are the PCs, and then you have your LAN connected to this, and then you have your, for example, this is the WAN connectivity that you have. So let me go and just wanted them break cable, something like that, not like that, but anyways, then let's go and connect this also. Okay. And think that here also you have your LAN. I'll not connect PCs and all, but this is one of the other LAN that we have. And okay, so I'll go and connect only one PC here, just for our understanding. Okay, so one PC, stay with me, connected. So this is the connection we have, and we have routers. So we have router 1, we have router 2, we have router 3, right? So what is the goal? Our goal is this, that the traffic that we have will go from here, right? Go from here, go from here, and reach here, right? So this is my source. And for example, this is the destination, right? So this is my organization. So let me quickly go and draw that this is my organization. This is my org. And this is something ISP. And this is my other branch. Source is my branch and destination is also my branch. So let me go and draw quickly. So this is, if I can draw, oops, can I draw? I need to draw. Anyways, no problem. Right. So source and destination, you understand this, right? Now what I want to highlight here is this very important. So I want to highlight this, that you can, when you will go and apply the QoS, right? So you will apply to the LAN facing interface and you will apply to the WAN facing oops. You will apply to the WAN facing interface, right? Here and here. Now let's focus at this point of time in only to the WAN facing interface, because LAN facing interfaces, the QoS you're applying is for classification and marking. Because in LAN facing interface, you have much throughput bandwidth. You are not worried about that. But when you are connecting to the ISP, sending your packet, then you're applying all sort of buffering, queuing, mechanism, scheduling, everything here. Okay. Likewise, when you'll go and apply the QoS, you'll go and apply to this interface, you'll go and apply to this interface. Now, when we are applying QoS to this interface, that is LAN facing interface, generally this is ingress, coming packet. Coming packet, do the classification and marking, then it can go to the IP phone, PC, any other device, video conferencing, etc. So incoming packets that we are doing, applying, is actually related to the classification and marking. But when you are applying the packets here and this interface, right? This interface when you are applying, that is actually inbound and outbound. From here outside, coming inside, both direction, in and out, both you're applying. But when you will go and apply the QoS in the LAN interface, then you will apply to the inward direction, because here you want just the marking, classification and marking, right? So that's a very important point that I'm telling you here at this point of time. By the end of the session, you can go and watch this recording. It's a very important part related to QoS, and it's a practical point. Now, what we want here, what I want to show you, telling you about the routing table. So QoS is different thing, right? Routing is different thing. That's something that you may have. So here I have only one interface, but this interface may have 200 sub interfaces, and you may have 200 LAN network, right? When we are talking about a LAN network here, for sake of simplicity, we have only one network, but you may have 10.1.1.0. You may have 10.1.2.0. You may have 10.1.3.0. Likewise, you may have so many other network. You may have 10.1.x.0, right? So you may have n number of network. These network, you have to go and define the gateway. So where you are defining the gateway will be defined on the layer 3 boundary. Layer 3 boundary, right? Either it's a layer 3 switch or router. So for example, for the sake of simplicity, that we have only one network like this. This is my network. And this particular network that we have, having gateway defined on this interface. This is my net gateway for all the network, right? Gateway means in your laptop also you are giving IP address, subnet mask and gateway, from where it will go outside and come inside. Gateway is defining because we want layer 3 communication. Suppose this is 1.1 and suppose this is 1.2. So they are part of same LAN network, right? Same place. So in this, you don't need anything. They can do layer 2 communication, right? From here to here, they can go and check the MAC addresses and they can chit chat with the help of this switch. This is one of the switch. They can do some local communication, right? But once you want to reach to some destination, this destination IP is, for example, 20.1.1.10, then the 10 network, right? This 10 network that you have here, it should go and reach out to this 20 network, right? 10 should reach 20, but who will know that 10 has to go and reach to 20? That is your router. Somehow the router, they have to go. So router knows his own network. Router know that, oh, I am belonging to 10.1.1.0/24. That's my local network. It will be there. Is my local interface, local network. But somehow I need to learn 10 dot, sorry, somehow I need to learn 20.1.1.0. That is some remote. So how they will learn? Routers, they have to build the routing table. Someone will send some advertisement via routing control packets and they need to learn. Likewise, router will send their advertisement. So how this particular router will know that he has to reach 10.1.1.0? right? Because this is a remote network for him, because his local network is a local network, right? So routers, they have to exchange their routing table, topology table. According to that, they will learn the local and the remote network, right? According to that, they will understand how to reach and where to reach. But this is not the full story. Full story you will understand when you will understand the fib versus rib, the MAC table, and the all those things. That means in the next session you will understand more about this. Oops. This philosophy that we are talking here is not like this much straightforward, but generally this is the way they are learning the network. So what is routing table is the best path to reach out to the destinations, right? Any doubt, any question in this? You can ask me if you have any doubt, please. No doubt, right? Like that, I will draw the diagram and I'll explain you. So don't worry about the classes and all, you will understand everything. I told you earlier that we just started. So don't worry about that. What we are going to do here, I'll quickly go and check if my viral session got started. Then I will build the lab in the viral, and then I will show you one example related to QoS. Likewise, you can also follow the same path. So let me quickly check the viral session. So once you go and utilize these credentials, then your lab is there. In my screen, it is showing very small because some resolution issue is there. Let me check this screen resolution so you can see this. And we don't have option to change the resolution. I need to change my laptop resolution. Let me go and do that. Display setting. Resolution. I think what? Maybe this one. Changes. Okay, now let's go back here. Now you can see it's big. Okay, so once you open the lab, you will see this type of dashboard, right? VMmaster. Once you open that, then you will see. Should I see the full screen? Still, it is actually loading. You will see this design page here, right? So if you click design, let me stretch it. And then this new page here, if you click this new page, it will ask you some name. So I'll go and give the file name lab1 viral. You should give the extension viral. Otherwise it will not work. Finish. So now new page will come. Once you have this new page, lab1.viral, then I want 2 routers and 1 switch. So I will go and use this, simply drag and drop. It's very easy. Like in GNS, just pick this, put here. Oops. Put one more, like 2 I have created. And then I need only 1 switch. So I'll go and click. It's not dragged up even. You click and it will work. Then connection is there. Like in GNS, you're doing the connection, just connect it. Once you have this lab connected and everything, then you should go and click this save button. So now you can see lab 1 is having no asterisk, that means it's a saved topology. This got saved. And if you want to do designing and replacement of the devices, you can do it. There's no problem. In the bottom, you can see some rectangles. So suppose this is site 1, this is suppose site 2, this is suppose ISP. Like that, you can change the colors and everything as well. All those options are there. Now, once you have this unsaved topology, you can see this become this asterisk and lab 1. Again, click save. So this lab got saved. Now you have to go and start this lab. This is just the topology part, right? So to start this lab, what you need to do, you have to go and start this Chrome. And then it will ask you username and password. I'll give you the username and password in the chat window. So give the username and password and click login. Let's see if it is correct. Yeah, it's logged in. Now, once you come to this particular page, you will see this option called launch new simulation. Simply click there and then call the local file. That's it. So now you can see that choose the file local variable. We need to choose the file that we have created today. So click choose file, and then it will redirect you towards the folder where you have the file. So you can see clearly here VM Master. Go there, go to workspace, my topology, lab 1 viral, and then click launch. That's it. Once you click launch, then within 2 to 3 minutes, you will get the telnet and the SSH port numbers for these devices, right? So just be here. It will become green. At the moment, this is amber because this is starting in the background. And then this reachability will become true, true, true. And then you'll get some management IP to log into these devices. Now you can see building, phase is building. And you can see some telnet IP is there. So it's something like viral demo, Cisco 1700. These are the telnet ports. So what I can do, generally I use secure CRT, and I'll go and create a new folder here. So I'll go and create new folder. I'll mark this as a viral lab, right? And once I have this folder, then I'll go and create new session here, new session, telnet, next, host name, let's pick host name, and the port number 17123, like this. Next, session name, I can go and give this is router RTR1, and then double click. Like that, you can bookmark in your super putty or empty putty as well. So from your laptop, you can go and log in. You have option here as well. Directly, you can telnet and SSH from desktop as well. Okay, I'll show that part as well. 1 second. That if you don't want, generally it's easy to use the way that I am using. You can see here these ports are there. You can see. So I can simply click here to the console. I should start from here as well, but you'll see that it will be little bit slow and all. But from there also you can start. You don't need to do empty putty and all. But it will be little bit slow. The other thing that you can do, that where is the topology? Let's go back to the topology here. VM master. If you come here to this VM master page, here it is, and okay, from here also you can start from this place as well. Launch simulation. The simulation is already launched. Oops, new simulation is coming up. But leave that complexity, that the way that I am telling, that's the easy way to start. Start like that. So once we have our lab, which is built and running, then you can go and do anything. So let's go and do host name router
Just
one
a
and
quick one. Which one do we have to go with? Because there's a bit confusing right now.
this one, this way, right?
You showed like two or three ways.
No, this way, just use
You
this method.
showed one that we can.
See, you build the lab, right?
It's not.
Your lab is
It's
built.
it's not clear
Then,
to me. It,
yeah, I'm making it clear now. So you have your lab, right? You built your lab, correct? So far, at this point, you're okay.
it's a little bit though.
So once you build the lab, then you will get the, once you launch the lab, you'll get this telnet IP. Just use this IP, that's it. No need to do any extra thing. Just use this IP to telnet. Okay. This is the URL and this is the port number. And you can log into the lab and you can practice. So what I have done, that I have telnet to this particular URL and port number, and I'm inside one of the router. If it is not clear, no problem. You will try from your side. You just watch the video recording, pause and play, pause and play. Try from your side. Otherwise, anyways, I am here to help you. Okay. All right. So QoS configuration. First of all, you have to write it down, the QoS configuration in the notepad, and then you have to practice it. So you have to go and create the policy map. For example, in the slide number, that is in the slide number 206, the name is 2P 6Q 3T. This is the name. I need, so before creating this, you should go and create the classes as well. Before creating the policy map, you should have the class map, right? So you should go and create some class map. This I have explained you about this match any or match all. So voice, this is in slide number 205. Prior to Q1, match the DSCP. For the voice, we are matching EF, expedite forwarding. Then I'll go and create the prior to Q2, and there I will go and match the DSCP CS4. This is there in the in our lab example. Then I'll go and create one more class. That class will be control management queue. These are just the class names that we are creating. Now we are matching the DSCP CS7, CS6, CS3, CS2. Right. Then match any. Then rest of the classes. So multimedia, conferencing, queue is the name of the class. We'll go and match the DSCP. Assured forwarding 31, assured forwarding 32, assured forwarding 33, like this. Then we have the class related to transactional data. So we'll go and create the match any transactional data. We'll go and match the DSCP AF21, AF22, AF23, and then finally we have the scavenger traffic. So for that also we'll go and create the class scavenger bulk data queue, and here we'll go and match the DSCP. That should be very low priority DSCP CS class selector 1, AF11, AF12, and AF13. So once we have all these class, then we'll go and call these classes within the policy. So we'll go to the policy map, and then we'll call these classes one by one. So now we'll go to class, this class priority Q1, and then within this class we can go and set the priority level 1, right? And then the policy rate percent 10. Then we'll go to the other queue that we have, video, that other class that we have. So what is other class? Other class, oops, okay, it should be video as per the document. So one is was, one is the video, but I have written as was, so I'll use it. Then here we'll go and use the priority level 2 as per our configuration, and policy rate bandwidth will go and give 20% bandwidth reservation. Now we have two classes. Now we'll go to the class number 3. Even you can exit and you can go to the class. So now we'll go to the class that we have created for control management queue, this one. So we'll go here, and inside that we have bandwidth remaining percent 10. If you want, you can use this queue buffer, but we don't have this queue buffer command in all the platform. So queue limit is there. That's okay. This is more than enough bandwidth remaining percent that you can go, and then you can go to the rest of the class. So other class is multimedia. This multimedia class will go there. Also we can go and give the bandwidth remaining percentage. So as per our diagram that we have seen in the slide, those are 10, 10, 10. In final last two classes, you have 5% and 25%. So here also this is 10. And if you want bandwidth remaining percent is 10. If you want, you can define the queue limit DSCP, and here it is like A43. You can go and give the threshold for this, maybe 80%. It's up to you. But this is very granular. This is actually very, very granular that we are doing here. This configuration is like within queue, you are giving some limit, queue buffer limit. Okay, likewise, you can move to next class, and that next class is, so after multimedia, what is that next class we have? After multimedia, we have created the class related to transaction data, or just you can follow that document that we have. So now we are inside the transaction data. Here also we can go and give the bandwidth remaining %10 or 20, like that. Here also, if you want, you can do the queue limit. And then finally, you can go to the class scavenger. So again, I can go to the class, queue. And there also I can go and give the bandwidth remaining %, maybe 15%, but just follow the document and the configuration. So if you do everything related to all the class, then finally you have class, right? Which is called class default. So in this default class, you can go and give the remaining bandwidth, because everything will go and add up to 100. So if I go and give remaining bandwidth remaining percentage, for example, percentage 50%. Oh, it's taking, but we should not do like this. It should go and check. So Q1 10, Q2 10, then media 10, so 30, then transactional data 10, 40, and then this 15, that means total is 55. That means remaining bandwidth % should be, for default class, in this example that I am doing here, it should be 45%. Then it will add everything to 100%. So now you have the class. Now you are calling the class within the policy map, and you are putting the bandwidth %. So what is the next thing? So in this example, we are creating policy map within policy map. So I'll go and create one more policy map. That will be, for example, 200 Mbps. That's the name. So I have 200 Mbps bandwidth in my WAN interface. Now I'll go and call the class called class default. And in this class default, I want to give some shaping average for 200 Mbps. That means 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, and 8. So I should give 8 zeros to make. And if you type question mark here, it will tell you that it should be in the bit rates. So bit convert to byte and all. You can go and do some Google conversion. So I just wanted to give 200 Mbps in bits. So it should be like this only. See, it is throwing error. That means I'm giving some more zeros here, which is not acceptable. Okay, so 1, 2, 3, 4, 5, 6, 7. Yeah, now this is 200 Mbps, so it's checking right. Now we'll go and call the service policy that we have created, the policy map here. What's the name of our policy map? The name of policy map is this. So you can go and do this. I'll do show IP interface. Now we have created everything, right? But we haven't applied it. When you have to apply it, you can go and check your WAN facing interface. So which is my WAN facing interface? Suppose this is my WAN facing interface. This is gig 0/1. So now I'll go to interface gig 0/1, do no shut. This is my WAN interface, right? So once I am here, I can go and give service policy, you can see input and output. I want to apply it to output in the egress direction, and then the name of the parent queue, that is 200 Mbps, and that's it. Our QoS is configured, right? So run class map. These are the classes we have created. Show run policy. These are the policy map we have created. Show run interface gig 0/1. This is the policy that we have applied to the interface, right? This is the way that you can go and do the configuration. Any question?